Assalamu alaikum, my name is Ahmed Saeed and today we'll be discussing the modified Euler formula. First, we need to look at the Euler's formula. This helps us to get numerical solutions of ordinary differential equations. The Euler's formula, or Euler's formula, is as follows: y1 is equals to y0 plus h which is the step size, into the function of x0 and y0. In order to use the modified Euler formula, we must find the initial value of y1 naught using the Euler's formula. Then we can use the modified Euler's formula to find an improved answer. So y1 1, which is the iteration number, is equals to y0 plus h upon 2 into the sum of function of x0 y0 plus function of x1 y1 naught, the value we found from the Euler's formula. Now, the number of iterations we do, the first one and the second one, you can see here that the equation is basically the same, only that we use y1 1 we found over here into the second time. We can do as many iterations as we want until both the values found from the previous and the next equation are same to 4 decimal places. Today we'll solve this particular example. In y dash is equals to x square plus y. We have to find y at this y when x is equal to 0.02. We know that y0 is 1, the step size is given as 0.02, x0 is 0, and thus x1, which is x0 plus h, is 0.02. Now how will we solve this? First, we use the Euler's formula. The formula is as follows, as shown before: y1 naught is equals to y0 plus h into the function of x0 y0. Now, what is the function of a function of x0 y0? X0 square plus y0, and x0 is 0, y0 is 1. Thus, solving the equation, 1 plus 0.02 into 0 square plus 1 is y1 naught 1.02. Now we have basically found the value of y1 at x is equals to 0.02, but as we are using the Euler's improved formula or the modified formula, we can find an even better answer that has better approximation and is closer to the actual value. For thus, we shall use the Euler's modified formula. We are going to find y1 1 which is equals to y0 plus h upon 2 into the sum of functions of function x0 y0 plus function of x1 y1 naught. So y1 naught is 1.02, which we found from the Euler's formula. Putting everything in the equation, and we found the y1 1 is equals to 1.0202. Now you can see that this is a better answer than the initial answer that we found. It is more accurate. Now we can do a second iteration to see that if our answer could be further improved. The second iteration, in which we shall use y1 1. We can see that after putting everything in the equation, we have found that y1 2 is also equal to 1.0202, which is the same as we found of y1 1. Thus we can accept this answer as the best possible answer we can find through Euler's modified method. This question has been solved. Thank you for listening.